Here is my last DER and second ISP of my grade 11 year, Project 2.8 Long ISP Duckman Camera Tracker. This project is essentially a more complex version of a basic security camera similar to the one you may see in a convenience store, and this is where I got my inspiration. With that being said, the real reason this project was pursued was to solve a problem. The problem in this case was that teachers were having to repeatedly alter their camera angle in class, and my solution? Well, you gotta keep watching to find out. To complete this project, there were three main steps, beginning with the circuit and the PCB design, followed by the code, and finally the design set of the project. Now to explain my circuit. You must first understand the brains of this operation, my project MCU, an Adafruit ESP32. The ESP32 is an absolute beast of an MCU, and is simply an upgraded version of the ESP8266. And this device is integrated with both Bluetooth and Wi-Fi capabilities. The circuit in this build is made up of 3 servos, 2 for the X and Y axis controlling the camera and 1 for an ultrasonic sensor, a couple of resistors, a switch, an LED, a couple of pots. The new component in this build, being an ultrasonic sensor, can be best described as an electronic device that measures the distance of a target object by emitting ultrasonic sound waves and converts the reflected sound into an electric signal. From there, the circuit was built into a custom square PCB using Eagle. Its schematic is on screen now. The second portion of this project, and arguably most complicated, was of course the code. In this project, the code was broken up into 3 portions using a pot and a map function, outputting values ranging from 1 to 3, corresponding to each of the 3 modes, Wi-Fi, manual, and automatic. Beginning with the first mode, Wi-Fi, was by far the most difficult due to the endless possibilities of error. The Wi-Fi portion can be broken down into 3 main stages: the setup, the initialization, and the user interface. The setup is where the server is ultimately created and where a lot of necessary information is printed into the serial monitor, such as the server's ID. The server's ID is the thing you need to copy and paste into the Google browser for my website to pop up. Next is the initialization, where there's just a bunch of if statements watching the index of the browser. For example, if 27 right pops up in the index, the servo on the x-axis moves to the right 5 degrees. Finally, there is a user interface, where the buttons and titles need to be created for my website to look nice. To do so, everything was coded, from the buttons to the title. Next is the manual mode, which is a lot simpler. 2 pots are read, then followed by a map function, which then remaps the resistance value down to the angles which the servos on the X and Y axis follow, all of which is then controlled by a switch to prevent outliers in the resistance from creating unwanted movement, which once flipped also turns on a red LED built into my MCU. The third and final mode is just an automatic mode, where essentially an ultrasonic sensor mounted to a servo is rotated, and if any values are shown with, for example, a human in a 1 meter range, the X-axis for the servo camera is turned on to the same position. Finally, I will explain the last portion of this build, the design. In this project, it consisted of a Fusion 360 mounting case, a beautiful acrylic finish, and a couple of other design choices made along the way. The Fusion 360 design, which is on screen now, is a bottom-heavy tower design. The bottom portion consists of both a servo case and my PCB case. The next basic design is used to hold the acrylic in place, which is essentially just a 3mm shelf going around the entirety of the case, so that the acrylic can sit comfortably on top of the PCB. Next, a hollow tower was created in an effort to cover the wires, and on its top, it holds the 2 servos that have the purpose of giving the camera 360-degree motion. Next, for the acrylic in this build, I wanted to keep it simple, leading me to create a basic design of a square with the project's name etched on it. This small design choice, although simple, was extremely meaningful as it ties the build together. The final portion of this design was the servo mount, which consists of 2 servos and connects them, as it sits on top of the 3D design case. The servo mount in this project was bought, and by using a couple of screws, it could be securely mounted to a webcam I also bought off Amazon. Ultimately, I'm incredibly proud of my first ever long ISP, and with all the new knowledge I've learned, I look forward to experimenting with it in future projects. Thanks for a great year, and see you next year.